everyone. So here we have a problem called flip2. So this is discussion number 8, question number 5. And so it says to write a recursive function. We're going to do it iteratively and recursively. So don't worry about if you're worrying about the iterative solution. But basically it's going to take in linked list S as an input and mutate S. So keyword mutate, not create a new linked list so that every pair is flipped. So if we pass in just a linked list with the element 1, then what we want to know about this is that since it's just one element, we're not flipping anything. So if we mutate it, we call flip2 on one link. One link should have changed, but there's nothing really to change, so it's going to stay link 1. On the other hand, if we had the linked list with the elements 1, 2, 3, 4, 5, what happens here, if we call flip2 of the link, remember that in the case of mutation, we don't really assign it back to a variable a lot of the time. But if we check what link is now, we notice that it's changed. So the first and second element have been switched, third and fourth element have been switched, fifth element has been switched. So we're not reversing the list, we're just like flipping pairs. So the first and second are switched, blah, blah, blah. And so yeah, so let's think about how we want to handle this. And so if you haven't already, take a bit of time, but I guess like a couple of tips that you might want to think of is consider what we're swapping one at a time. So how do we handle one swap and how do we move on to the next set of swaps? And so yeah, so the idea behind this is that let's say we have the list 1, 2, 3, 4, 5, is that we're gonna handle swapping one set of elements at a time and then moving on to the next set, recursively swapping each of them. And so for example, we have this set right here, and then if we wanted, let's say this is link right now. If we wanted to swap the 2 and the 1, how would we go about doing this? What we would do is that we would say link dot first. So right now it's that 1, and then comma link dot rest dot first is equal to link dot rest dot first comma link dot first. So link dot first is that 1, link dot rest dot first is that 2, and what we're doing right now is swapping both of them. So now it's going to be 2, 1. And so we got the first swap down. And now what we want to do is that we want to move on to the next set of swaps. So this 3 and the 4. And so we're going to make link go all the way down to link.rest.rest. So link.rest is this thing right here. And we want to move on to the one after that. So we want to skip by 2. So link.rest.rest is now here. And then we're going to do the same thing. We're going to say link.first and link.rest.first equals this swap. And you can imagine if we're going to do it recursively, that this link.rest.rest call is going to be like a recursive call. That's flip2 of link.rest.rest. So right now we handle switching the 1 and the 2. And if we call flip2 of link.rest.rest, so the rest of this linked list, then it should handle swapping the 3 and the 4 and that 5 if applicable. But in this case, we don't really swap the 5, so yeah. But yeah, so we're going to, and in the case of the iterative solution, what's going to happen is that we're going to say link, we're going to change it to link.rest.rest, and then it's going to keep on going on. And we'll see what it's like later. But yeah, and then so what happens here is we do the same thing. So link.first, link.rest.first, we're going to swap them, and it becomes 4 and 3. And we're going to move on to the last part. So now our link pointer is pointing at the 5 node at the very end. And the thing to know about this is that there's only one element left, so there's nothing really to swap it with. And so how do we know this? We notice that link.rest is link.empty. Since the 5's at the very end, it should be pointing to this link.empty thing, which signals the end of the list. But yeah, and also one thing to note is that when you're swapping elements, so in the case of link.first and link.rest.first, you have to have that guarantee that link.rest isn't link.empty. Because remember that link.empty isn't a linked list, and so you can't say link.rest.first is valid if link.rest is link.empty. So you need to make this check anyways if link.rest is link.empty, because if it is, then you can't access .first, otherwise you can. But yeah, and so let's get into the code. And so let's start off with maybe the recursive solution. So remember that with the recursive solution, how we want to handle this is that we want to handle one swap of the first two elements, and then our recursive call is going to handle the rest of the swaps. So there. And so we can start off with, remember that we want to make that check if it's like link.empty or if the rest is like link.empty. So if s is link.empty, so if s is link.empty, then there's nothing in the list, there's nothing to swap at all. And in addition, we want to check if s.rest is link.empty. Because if s.rest is link.empty, that means there's only one element left in the list, and so we don't want to swap that like only element with anything because there's nothing else to swap with. And one as an aside, make sure you don't say like s.rest is link.empty or s is link.empty. So in this case, the order does matter. So if you say s is link.empty second, then what happens is that, what if s is link.empty? Then you try to access .rest, and .rest doesn't exist for a link.empty. So because of that, it's going to error in some cases. So you always want to have s is link.empty first, and then followed by s.rest is link.empty. So you're guaranteeing that s is a linked list, and from that you can access s.rest. But anyways, if it's either of them is link.empty, then we don't want to do anything, and we want to just return. And on the other hand, now we want to like swap these two elements, right? So s.first, s.rest.first is equal to s.rest.first, s.first. And so we swap those two, and now we want to move on to the rest. And so now we can say flip2 of s.rest.rest, and you can imagine that in this case, the 3 and the 4 got swapped around, and this recursive call should mutate the rest of our list. And yeah, so that's going to be flip2. And now let's move on to the iterative solution. So the iterative solution is like pretty similar. So remember that here now we have like a while loop, and then so maybe like while s is not link.empty, so while it isn't an empty list, and this is like the pretty basic structure that you're going to see for all linked lists. So while this linked list is not linked.empty, but in this case, remember that we also want to make this check that s.rest is not linked.empty. Because remember that to swap these elements, we have to make sure that there are two elements in the first place. So, or s.rest is not linked.empty. Oh, and actually. So we want to make sure that both of these are not linked.empty. And then so what we want to do after this is say that, what's it called? We want to swap the two elements. So s.first, comma, s.rest.first is equal to s.rest.first, s.first. And then after we swap these two, remember that we want to move our pointer. So s should now become pointing to like the rest of the linked list. So we just handled like swapping the 1 and the 2. Now it should be pointing to like the third element. And then we can like repeat it over and over. And it's kind of like recursive in a sense. It's like contained within that while loop. So now we say s equals s.rest.rest. And it's going to keep on going. It's going to swap. And it's going to move over two elements in the list, and etc. Yeah, and at the very end, theoretically, all of this should be mutated. You're going to keep on like swapping two until you reach the end. Either there's no elements left or there's one element left. And then we should be good to go. And yeah, that's going to be flip2. And let me know if you have any questions. And hope you have a great day.